Good day, learners. This is engineering. This time we're going to talk about Charles' law. In a gas, its physical behavior is described by these four variables, namely pressure, volume, temperature, and amount or mole. In this video, we will have Charles' law, which is concerned in the relationship of volume and temperature. Charles' law was formulated by the famous scientist Jacques Charles less than 2 centuries after Boyle's law in 1800. This law describes how gases will expand when heated. In his experiment, he prepared a test tube with trapped air under a small mercury plug. It was immersed in water bath with heating coil for heating and cooled with ice. Upon changing the temperature, the volume of the gas trapped in the test tube also changes. Having all the data, he then found out that volume and pressure follows this graph as shown. It can be seen in the graph that there is a dashed line portion because, theoretically, when gas reach absolute zero temperature or negative 273.15 degrees Celsius, the gas occupies zero volume. But no one has ever seen this phenomenon. The temperature's unit is in Kelvin for SI unit or Rankine for English unit. When we write it in mathematical terms, we have volume is directly proportional to temperature. This relation can be also expressed as the volume over temperature is equal to some constant. If we have a gas under two different conditions, we can write the formula as V1 over T1 is equal to V2 over T2. In the formula, we can see that under a certain condition of the gas, increasing the volume would result to increasing the temperature, or decreasing the volume would result to decreasing the temperature. For example, the initial volume is 5 liters at 30 degrees Celsius. What is the volume if we increase the temperature to 50 degrees Celsius? We first identify the given. We have the temperature must be in Kelvin. So we have, now we are going to find the final volume. We substitute the known values to the formula. Solving for the final volume, we have, so therefore the final volume is 5.33 liters. The volume is increased by 0.33 liter. So that's it. That is all for now. I hope you learned something today. Once again, this is Easy Engineering.